Okay, so as we're approaching the end of this remote learning period, we're going to have a couple of lessons where we're looking at powers and indices and powers of 10. So tomorrow we'll be looking at standard form, but today we're just going to look at laws of indices. And to kick off, we'll do a little APK on some work that we did back in the autumn term. So let's have a read of this question, and then what I want you to do is pause the vid and see if you can remember how to do this. So write the number 720 as a product of its prime factors in index form. So pause the clip and see if you get the same answer as what I'm about to do. So prime factors, you need to remember what prime numbers are. Prime numbers are numbers that have only themselves and 1 as factors. So 2 is a prime number because only 2 divides into it, and 1. 3 is a prime number, the same reason. 4 isn't because 2 goes into it. 5 is. 6 isn't because 2 and 3 go into it. 7 is. 8 isn't. 9 isn't. 10 isn't. 11 is the next one, and so on. So those are the prime numbers. So the method that I showed you for breaking this down into its prime factors is to start off with a number and put it in a little bubble, and then you're going to divide that number by the smallest prime number that goes into it. It's an even number, which means I'm confident that 2 will go into that, and 2 will go into that. 2 goes into 72 36 times, so that will be 360. It's an even number, so I can divide by 2 again. 2 into 36 goes 18 times, so that'll be 180, which I can divide by 2. 2 into 18 goes 9 times. 2 into 90 goes 45 times. So now I've got a number that I can't divide 2 into because it isn't even, but it ends in a 5, so I know 5 will go into that. And 5 goes into 45 9 times. 5 9s are 45. 9 isn't a prime number, but 3 is, and 3 will divide into it 3 times. So we keep that repeated division going until all the numbers that we're left with are primes. So once I get that 3 there, I can stop. So then that means that I can write 720 as 2 times 2 times 2 times 2 times 5 times 3 times 3. So if on my calculator I typed in that sum, the answer that comes out is 720. So that is a product of its prime factors, but then the sting in the tail is this part here, which is in index form. And if you remember, what we do for that is we look at the 2's that are multiplied by themselves, and they're multiplied by themselves 4 times. So I can write that as 2 to the power of 4. I've got times 5, and I've only got 1 5, so I can write that as 5 to the power of 1, or I can just write it as 5 and we don't bother putting the 1 in, and then times 3 squared. So the first point then is 5 to the power of 1 is the same as 5. So if you're given the number 5 and you want to put an index to it, a power, then it's to the power of 1, not to the power of 0, as we'll see later on with today's work. So that's writing that as a product of prime factors in index form. Now when we were practicing this, I was then asking you questions like, how can I tell that that is or isn't a prime number? Okay, and I know it isn't a prime number because one of my powers, my indices, these are called the index values, because one of them is odd, it means that it's not a prime number. If it was a square number, if it was a square number, then each of these powers, these indices, would be even digits. So it's not a square number. And then the other question I was asking was, well, what's the smallest number I'd have to multiply it by to make it a square number? And for that to become a square number, this is my odd power, so I would have to multiply it by another 5 so that I've got a 5 squared. So if I had 2 to the power of 4, 5 squared, 3 squared, that would be a square number. Right, so these are index form, and this is where we're going to be developing in today's work. Okay, and another thing for you to be aware of is if you've got 2 to the power of 4, these bits have got names. That, as I mentioned, is the index, and this is called the base. So we raise a base to a power or an index. Okay? So numbers written in index form with the same base can be multiplied and divided easily. So going back to what I've got here, I can turn the 2 times 2 times 2 into a base and an index. I can turn the 3 times 3 into a base and an index, but I can't simplify that and that. The bases are different, so I can't combine them any further. I can evaluate them by working out what the answer is, but I know that that is 720. So moving that into today's work then. Numbers written in index form with the same base can be multiplied and divided easily. For example, so if I was given 3 to the power of 5 times 3 to the power of 4, I know that this means multiplying 3 by itself 5 times. So that could be 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. And then I'm multiplying that by 3 times 3 times 3 times 3. So in effect what I'm doing is multiplying 3 by itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So that is 3 to the power of 9. Now if you look at the index values you've got here, you can arrive at the number 9 by adding those powers together. And that's the first rule of indices, that when the bases are the same and you're multiplying them, you can add the powers. So this is the same as 3 to the power of 5 plus 4, which is 3 to the power of 9. So when multiplying, same bases, add the powers. Okay, so the bases are the same, they're all 3's, so I can add the powers together. Now when we're dividing, same idea. If we write this out longhand, what I've got here is 5 to the power of 9, which is 5 times 5, so 5 times itself 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm dividing that, and I can write divide, as you should know, by a fraction, so 1 over the other. So that's the same as 5 to the 9 over 5 to the 7. So underneath here I'm going to have 7 lots of 5 times itself. 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. And what you can then do is cancel. So you can divide the top by 5 and the bottom by 5. Top by 5, bottom, and you can repeat this until you run out of 5's, either in the top layer. I've gone wrong there, no. So those, there you go. I can't talk and cross at the same time. So what I'm left with there is 5 times 5 on the top, and on the bottom I haven't got 0, I've got 1, because basically I've divided 5 goes into 5 once, 5 goes into 5 once. So that's the same as 5 times 5 over 1, which is just 5 squared. So if you look at the starting indices that we've got, I got a 9 and a 7, and I end up with 2. So that's the same as 5, and I'm subtracting the indices to get 5 to the power of 2. So when you divide the same bases, we subtract the powers. Okay, so if we look at this one now, well, I know that if I've got 2 to the power of 6 divided by 2 to the power of 6, that's going to be 2 to the power of 6 take away 6, which is 2 to the power of 0. Now, I also know that when I divide any number by itself, 3 divided by 3, 1000 divided by 1000, 265 divided by 265, I get 1. So I know that any number divided by itself equals 1. Yeah, e.g. 256 divided by 256 equals 1. 3.1 divided by 3.1 equals 1. 2 to the power of 6 divided by 2 to the power of 6 equals 1, because they're the same number. So therefore, anything to the power of 0 equals 1. So 2 to the power of 0 equals 1. Now, if we look at this one, we know that we've got 10 to the power of 3 divided by 10 to the power of 5. So if I write this out longhand, I've got 10 times 10 times 10 over 10 times 10 times 10 times 10 times 10. So I can knock 10, 10, 10, 10, 10, 10. I then got to stop because I've run out of 10s on the top. But I know there's a 1 there. So just like I got 5 times 5 over 1 up there, I've got 1 over 10 times 10 here, which is 1 over 10 squared. Now, using the laws of indices, this is the same as 10 to the 3 take away 5, which is 10 to the negative 2. So what that means is 10 to the power of minus 2 is the same as 1 over 10 to the 2, and this is called the reciprocal. So 1 over 10 to the power of 2 is the same as 10 to the minus 2. So if you see you've got a negative power, you can get rid of the negative power by writing it as 1 over that. This is known as the reciprocal. So certainly in advanced maths we go each way. Sometimes it's better to write something like that, sometimes it's written like that. So this is the reciprocal, 1 over. Okay, and that's quite, they like in an exam paper to ask you about the reciprocal. So write in index form the reciprocal of 3 squared. So the reciprocal of 3 squared means 3, it means 1 over 3 squared, and in index form that means 3 to the power of minus 2. Second one, the reciprocal of that means 1 over that, which is 3 to the plus. It changes the sign. And then the final one, the reciprocal of 4 is 1 over 4, which I can write as 1 over 2 squared, which I can write as 2 to the minus 2. So with the reciprocal, you see the word reciprocal, it triggers 1 over, and then to write that in index form, you can bring it up and change the sign on the power. Okay, you could get a question where you've got a combination like this, and you can do this all in one go. Okay, I know that the base of that is 2 because they're all in terms of 2, and I know that I'm going to add the top powers together, and then I'm going to divide by the bottom power. When I'm dividing, I'm subtracting. So that's going to be 2 to the power of 5 plus 4 is 9, take away 10 is to the power of minus 1. So you could either write it as 2 to the power of minus 1, or I know that that's the same as 1 over 2 to the power of 1, and if we go back to what I wrote there, whether you choose to write the power of 1 in or not is up to you. So that's a half. So that simplifies to 1 over 2, or a half. F. 9 times 3 to the power of 5 can be written as 3 to the power of n. What's the value of n? So this is basically saying, at the moment I've got there a product where I'm multiplying two parts together, but I can write it as a combined indice. And I can do that by recognizing that, 9 is 3 squared. So that's the same as 3 squared times 3 to the power of 5. And now I can add the powers together. So 9 times 3 to the power of 5 can be written as 3 to the power of 7. So n is 7. And we can take these rules further. There's higher tier indices that we don't have to worry about. So the next ones we're just focusing on at intermediate tier. So if we think here that I've got 5 to the power of 4, and then I'm raising all of that to the power of 3. So what I'm doing here is basically 5 times 4 times itself, 5 to the power of 4 times itself 3 times. So I'm taking that and I'm multiplying it by itself 3 times. And when I'm doing that, when the bases are the same, I add their powers. So I'm adding 4 to itself 3 times, which is 12. So just like I did with the earlier relationships, if you look at the starting numbers you're given here, when you're raising a power to a power, you multiply them. So here, that's going to be the same as 5 to the power of 4 times 3, which is 5 to the power of 12. So when raising an index to another index, multiply the powers. So I'm changing my word for index to power. They mean the same thing. Okay, it's the little number that's instructing you how many times to multiply it together. So 5 to the power of 4, all raised to the power of 3, is the same as 5 to the power of 12. But if you can't remember the rule, just do it like that. Then the other crucial one which you've got to remember, you've got to learn this, is that the square root can be written as a power as well. It can be written to the power of a half. So if I've got 2 to the power of a half, that means the square root of 2. If I've got 64 to the power of a half, that means the square root of 64. And because 64 is a square number, I can simplify that, because what the square root is asking you is what number times itself makes 64, and the answer is 8. Okay, so let's have a look at what we've got here. What I've got is that I'm working out what the square root of 4 times the square root of 4 is. I know that the square root of 4 is 4 to the power of a half, so I've got 4 to the power of a half squared. And I know that when I'm raising a power to a power, I multiply, so I get that, and a half times 2 is 1, and anything to the power of 1 is just itself. So what this is saying is, if I take the square root of 4 and times it by the square root of 4, I get 4. I just get back to the start. Same here. What I can do here is I can write that as 4 squared times 3 squared to the power of a half. And that means I do each of these powers multiplied by a half. So I'm going to get 4 to the 2 times a half times 3 to the 2 times a half, which is 4 to the 1 times 3 to the 1, because 2 lots of a half is 1. 4 to the power of 1 is just 4, 3 to the power of 1 is just 3, so that's just 4 3s, which is 12. Now all of these rules that we've looked at are when you are multiplying or dividing bases where numbers where the bases are the same. Okay, where you've got to be careful, where they like to trip you up, is by lobbing in an add or a subtract, where these rules don't work. Okay, so if they're asking you to evaluate, that means they want an answer, so they want you to work this out, and what you have to do is work out what 2 to the power of 4 is, which is 2 times 2 times 2 times 2, and 2 times 2 times 2. So 2 2s are 4, 4 2s are 8, 2 8s are 16. So 2 to the power of 4 is 16. 2 2s are 4, 4 2s are 8. So what we have is 16 take away 8, which is 8. So when you are dealing with a simplify or an evaluate, and they're not multiply or divide, you've got to work out what the numbers are. Same with this one. This one's going to be 3 times 3 times 3 plus 2 to the power of 4, which we've worked out in the previous example. 3 3s are 9, 9 3s are 27, plus 16. And 27 and 16 is 43. Okay, so those are the relationships that you need to be comfortable with when working with indices. Okay, they're grade B questions. Some of them are a little bit easier, grade C, but there's certainly things that you need to have a handle on. They don't take a massive amount of revision, and often, if you can't remember the rules, you can go back to the sort of easy steps and work out what those rules are. So what I want you to do now is have a go at the questions on slides. As I put on the first question, because you're probably typing your answer, it's not easy to write 2 to the power of 4 like that. You've got to go into equations editor, which is a pain in the butt. So on your keyboard you would write that as 2 to the power of 4 with a little up arrow, which on most keyboards is Shift 6. On a normal keyboard, not your calculator one. Okay, so give those a go. Hopefully they're not going to take you long. I don't need you to you know, write out your answers in a detailed way. Just give me the ones that you've got, and then as usual I'll upload my video solutions, and any that you get wrong you can watch me working out like that. But what I think you should do is have a go yourself on paper to lay them out like that, and then transfer your answer over onto the slides. Okay, so I hope those go okay for you.